So for this lesson of chapter 6, we're going to be looking at models of sinusoidal functions. So what we've been looking at so far is being given an equation and knowing how to graph it. So now we're going to be looking at the opposite. If I'm given a graph, how do I go backwards, if you will, and figure out what the equation would be? So like it says here in this section, we will try to determine the equation of a sinusoidal function from a graph. So here's an example, just to move this up. The height of a nail, height over time. So determine the equation of the following graph. Now, first, I'm just going to give you hints that you can refer back to, that we will refer back to as well with every example that we do in this lesson. So the first thing you have to do is decide if the function is best modeled by a sine curve or a cosine curve, right? So we know that sine normally starts at 0, right? And cosine normally starts at 1. So here are some tips and tricks. Any sinusoidal function can be modeled by either sine or cos. The only difference is that then you will have a phase shift of the curve, and possibly the a value, you'll have to change the sign and make it negative. So this is just kind of the easiest way to refer back to this. So if the graph starts at its maximum, so like for example, this particular graph, right? That is the highest value and it's starting off at its highest value. So if the graph starts off at its maximum, it is best modeled by the cos curve. Oh, don't have my pencil. It is best modeled by the cos curve. If the graph starts at its minimum, so let's say this lowest value was where it started. Along the y-axis, it was starting at the minimum value, going up, coming down, right? So if it starts at its minimum, it is also best modeled by cos. However, then you need to make the a negative, your amplitude. So then I need to make a negative. And then down below that, if you have printed out the PDF, it's going to say if the graph starts along the axis of the curve. So meaning if I'm starting here along the axis and I have part of it going up, part of it going down below, part of it going up, part of it going down below. So that's the equation of the axis. That's going to be best modeled by sine. So sorry, I just have to clear this to move it up. That is going to be, if it starts along the axis of the curve, it is best modeled by the sine curve. So for the values of a, k, d, and c, we will use the following equations. So this is for any graph. How am I going to figure out my a, which is my amplitude now? So the same formula I had back in 6.2, max minus min, or even 6.1, I believe, max minus min divided by 2. So the subtracting one, my k value. So if you remember before, just to put off to the side somewhere, my period, right, would have been 360 divided by k. So if I were to rearrange and have over 1 and cross multiply, k times the period equals 360 divided by the period on both sides to get k by itself, then I would have k equaling 360 divided by the period in this case. So that's rearranging to solve for k, 360 divided by the period. And c, that's the equation of the axis, right? We learned in the last video. So the equation of the axis is y equals c. So that's going to equal the max plus the min divided by 2. Because remember, the amplitude is max minus min divided by 2. Equation of the axis is max plus min divided by 2. Okay, so let's talk about this a little bit more before we go back up to the top, which we will do, and try to get the equation of that graph up here. Some graphs will not have their y-intercept as the maximum or minimum, or it won't be starting like along the equation of the axis of the curve. So for these functions, it would be necessary, then you know that you have a phase shift. So we're going to be looking at one of those now. So in order to figure out the phase shift In this case, I would always recommend choosing the cos curve. So using a cos function as your equation and identifying the phase shift to the nearest maximum or minimum. So again, we will do one example of that, right? Cos normally starts at 1. So kind of how far over are you from 1 as a maximum or minimum to determine your phase shift. So use this information to determine the equation of the function shown above. So why don't we just go back up above instead of writing it out here. Let's go back above and we've got room here to write it there, right? So if I'm looking here, it starts at a maximum. So let's use a different color so we can refer. So it's starting at a maximum value here at 3, right? So if it's starting at a max, I go back to my list there right here. If it's starting at a max, it's best modeled by cos. So let's just say maximum means I'm going to be using the cos curve, and it doesn't need to be negative. It's only negative if it's starting at a minimum. So my general equation, right, my y is h of t in this case, and my theta that I've used before is now t, time and height. So I have to use that as part of my equation. So it would be h of t, which is like my y value, is equal to, right, a, and then I'm using cos and not sine, or if I was, I would use sine, bracket k, right? It's normally x minus d or theta minus d. In this case, it's t minus d, double bracket plus c, and that is a t. I just kind of didn't write it so neatly there. So now let's go to our formulas that we just did to figure out our a, our k, our t. Do we have a d and a c value? So my a is my amplitude is equal to the max minus the min. That's easy enough to read off the graph, right? Divided by 2. So the maximum is 3. The minimum, the lowest value is -1. So don't forget you'd have a double negative there. So that's 3 plus 1 is 4 divided by 2. So my amplitude is 2. And in that case, I don't need to worry. It's not going to be negative because it's not a minimum, right? So the value of a would actually be 2. So now the next variable to solve for would be k. Remember, k was equal to 360 divided by the period. So I have to take a look at how long the period is here. So 360 divided by, so here it starts at the top, comes down to a minimum, the trough, comes back up to the top, so right there. And then is it repeating? It looks like it's repeating, right? Back down, back up, back down, back up. So this would be 3 cycles here that would take 30. So you could just take 30 divided by 3 to get 10, or just look at where the first cycle ends. And the first cycle ends, it takes 10 seconds. So the k value is 36, 360 divided by 10. Now my d here, my phase shift, again, that's if it doesn't start at a maximum or a minimum or along the equation of along the axis here. So I don't have a phase shift here. So that's 0. And my c value, remember, is the equation of the axis. So max plus min divided by 2. So 3 plus -1 divided by 2. Well, 3 minus 1 is 2 divided by 2. So that would be 1. And then I go ahead and rewrite it into my formula. So therefore, h of t is equal to my amplitude A, 2 multiplied by cos, bracket, my k value is 36, times t, because it's not an x or a theta in this case. And it would be a d value, but I don't have a d value, so I close my bracket and plus 1. So 2 cos bracket 36t bracket plus 1. Okay, now I know this is new. It's nice to have the formulas, right? Because the formula is easy to figure out a and k and c really. So it might be the hardest part, just figuring out if it's sine or cos. Is cos going to mean the amplitude is positive or negative? And then again, we'll practice a phase shift in there as well. Let's just do another relatively simple one down here. Determine the equations of the following sinusoidal functions. So we're talking about that's A and B, and then we have a separate example there. So let's look at A here because I can write above it, okay? So determine the equation of the following sinusoidal function. So again, the first thing to start with would be to say, this is along the y-axis here, right? Am I starting at a max or a min? I am. I'm actually starting, if you look at the graph, I'm starting at a minimum value along the y-axis. So if I start, if you go back up to the top with what you wrote down, if I start at a minimum value, did that say to use sine or cos? If I start at a min, remember I'm going to use cos, but my A is negative. My amplitude is going to be negative because cos normally starts at +1, right? Which is its maximum. So because it's starting at its minimum, it's cos, but A is negative. Okay, so let's get started with the A value then. So my A value is max minus min. We probably have that memorized pretty soon by now, just from writing it out all the time. So this is easy. What's my maximum value? My maximum value is negative 0.5. Minus my minimum is negative 1.5 divided by 2. So that ends up being negative 0.5 plus 1.5. So negative 0.5 plus 1.5 would be 1 divided by 2. So that's 0.5. Sorry, I want to erase that just so it looks better, no confusion. So that's 0.5, but don't forget here, right, that A is negative. So my amplitude is 0.5, right? So if this is my halfway mark from 1 to 0.5, right, that's my amplitude. Or you can see here from the middle here down, right? It doesn't matter if it's going up or going down. The amplitude is always a positive number. We're at a distance here of 0.5, but because I'm using cos and cos is starting at a minimum, I'm going to add the negative in there because of this, even though the amplitude is actually 0.5. So we have the amplitude done, negative 0.5. Now let's go to the K value. So the K formula is again 360 divided by the period. So here I have to go to the graph and I have to look at what is one cycle. So if I'm starting at the minimum, going up to the maximum, going back down to the minimum, and then it would repeat, going back up to the maximum, you can see here. So the distance from 0 here, right, to what is this number? It looks like it's going by tens, 10, 20, 30, 40, because that's 50, 60, 70, 80, 90, 100. So just confirm that. So that would be 120 there, right? 2 lines away, and then that's 30, 40, 150, just to double check. So then that is 360 divided by 120, which, right, you could just cross out the zeros and say it's 36 divided by 12. So 12, 24, 36 would be 3, right? So now the D value, because I am starting at a max or a min or right along the axis, because that is true that I'm starting at a min, I don't have a D value, right? I don't have a phase shift, which that makes it easy. And then my C value is again, max plus min, adding the two together. So my max I already know is the negative 0.5, but this time I'm going to add negative 1.5 to it. So if I'm at negative 0.5 and I'm adding another negative 1.5, then that's going to be equal to negative 2 over 2. So my C value is negative 1, right? And then just plug that into an equation, which I'm going to put it down here for room in black. So I have my equation is y equals A is negative 0.5, just because it is reflected over, we don't know what this is, if it's theta then or what time, what it would be. So negative 0.5, and then we're using the cos curve. And then we put a bracket, and then we put our K value, which is 3. So 3, again, we don't know, we're gonna call this x, so 3x, but because I don't have a d value, I can close my bracket and then subtract 1. Let's take a look at another one here. And this is a little bit more difficult, what I was talking about before. This one, not to give it away, but we will have a phase shift here. So again, the first thing to determine is, am I going to use sine or am I going to use cos? So here it was saying if I'm starting right at a maximum or at a minimum value, like the previous 2 examples did, we would start at cos. Well, here I'm not starting on the y-axis I'm looking at, right? So here's my y-axis here. So 0.5, 1, 1.5. So it looks like it's crossing at 2 along the y-axis. And I could call this the x-axis because it doesn't look like it's degrees or anything like that. This value of 2 is not a minimum value. It's not a maximum value. So in this case, I said, because it's not starting, also the graph is not starting along this x-axis where I would use sine, they said the best thing to do is start with cos and then figure out what your phase shift would be. So here I know that I have a phase shift because I'm not starting along the y-axis. This is not the lowest value. This is not the highest value, and it's not starting along the x-axis to be sine, right? So I'm not starting at a max or min or at the axis of the curve. So I'm going to, step 1, use cos and determine the phase shift. Use cos and, sure, we'll say that, and determine the phase shift. So in this case, I'm just saying I have a d value, right? So I know I'm using cos. So cos normally would start at a maximum, correct? So cos would normally start at, let's say, 1, but that would be the maximum. Come down, come back up, come down a -1, come back up. In this case, this is my maximum, and I have to be careful here. Again, I'm playing around with this to see if I can zoom in for you guys without wrecking the video or anything here. Just that's probably the closest I'm going to get. And if I move this tool out of the way that you guys cannot see anyways, but for myself, then I would probably get a straight line here. Just to show you, I can kind of see that this maximum, it doesn't look like it's exactly in the middle of these 2 lines, because exactly in the middle would be, somewhere here. And that looks like it's just to the right. So if I were to pick this maximum the best I can and go straight down, what value is that? And you can see here that it looks like it's going by tens, right? 10, 20, 30, 40, 50, one grid line, 60, 70, 80, 90, 100. So 110, that looks like 120, 30, 40, 50. So again, if it was smack in the middle, it'd be 125. And when I did a straight line, it looked like it lined up with 120. So this maximum is supposed to be along the y-axis. So I have been moved to the right like 120 degrees. I have shifted to the right, or if it's not degrees and it's just X, still it's shifted to the right 120 units, if you will. So let me move this back out. That was just to kind of show you that. Come on, or else I'm not going to be able to write on this. Here we go, perfect. All right, so we're right here. Zoom in a little bit more so that we can answer this. All right. Just getting things back in order for myself here, moving things around that you cannot see, and back to my drawing tool. So I've figured out here that the phase shift D is I am shifted to the right 120 degrees. D equals 120, so I move to the right 120. So actually in the brackets would be X minus 120, right? So now I can go back and figure out my A and my K and my C. So my amplitude is the max. These are the simple things, right? Minus the min divided by 2. And let's get that off the graph. The maximum value looks like 5. I know it's hard to see. The minimum value is happening right at 1 there. So 5 take away 1 is 4. 4 divided by 2 is 2. And so my amplitude is 2. Now for my K value, let's move it over. Let's go here then. K is equal to 360 divided by the period. So 360, I have to take a look at what the period is. So from the time that I start here, let's just erase these extra marks that aren't in the right place from zooming in and out. So if I start here at 2, I'm going up to my maximum, I'm going down to my minimum, but when am I back at 2? So I'm back at 2 right there. So again, I need to get a straight line going on there to look at what number that is. It's hard with the cross, but it looks like that'd be 350. It looks like it's 1 over from 350, which makes sense because 360 degrees is a full cycle for a regular curve, right? So it's starting at 2, going up, going down, ending at 2, starting at 2, going up, going down, ending at 2, and that's taking 360 degrees. So if I go back here and take 360 divided by what the period is to do one cycle is 360, the K value is 1 then in that case, right? And my C value, which would be my equation of the axis, is max plus min divided by 2. So my maximum again was 5. I can just pull the numbers even from here. Plus 1 divided by 2, so 6 divided by 2. I have an equation of the axis at 3. And if I were to take a look at that, if I were to draw a line here at 3, it should look like it's dividing this curve directly in half, and that my amplitude then from here down and from this point here to the top is from 1 to 3 is 2. Just to draw that in, my amplitude looks like 2. And that's what I calculated that it was right here, right? Starting at 3 and ending at 5, right? Whether you go to the peak or to the trough, your amplitude A is equal to 2, just to show that there. So is there anything else to figure out? I think I have everything. Now it's just a matter of writing it out into the equation. So y is equal to, I've chosen cos, but my A value would go first. So my A value is 2. So y equals 2 cos of bracket. Then my K value, right? But my K value is 1. So I just put in basically, I don't have to put the 1, so just X, kind of like with a 1 in front of it. And then my D value is 120. So again, if it's right, it's always the opposite. Think about what's going in the bracket. So if it was negative in the bracket, I would move it right, which is what I want, right? If it was a positive in the bracket, I would move it left. So because I've shifted from along the y-axis as my maximum, that has been shifted to the right 120 degrees. In the bracket, I'm putting negative 120 so that I move right 120 degrees. And then my C value of 3 would be a positive 3. So there we go. I've come up with the equation. It might look daunting. It might look like a big task at first, but again, like everything we've done so far in math and in any grade besides grade 11, you always just take it one step at a time, right? So let's look here at this example here. If I'm not given a graph and I'm just given information, this is a separate example here. So just this part here. So a sinusoidal function has an amplitude of 2 units. So maybe we should be underlining this stuff. So I know that my amp is 2. I know that the period is 180 degrees. I know I have a maximum at 0 and 3, come up with the equation, but they come up with the equation in two different ways. So first, let's just come up with an equation first, then we'll worry about writing it out as a second equation that looks a little bit different. So let's kind of graph the information that I know, right? I know my amplitude is 2, but I know that my maximum point is at 0 and 3. So if I were to draw a graph, right, at 0 and 3, I have my maximum. So then I have to be careful, and I know that the period is 180. So again, if I'm usually going, 45, 90, 135, 180. So let's say I'm just drawing out 90 and 180 there. And if that was my period, then it would be coming down and coming back up to 3, and then repeating itself and coming back up every 180 degrees, right, is my period. But this amplitude, what do I do about that? Don't forget that the amplitude is the distance between halfway through the graph to the top and halfway to the bottom. So if the amplitude was 2, I've got from halfway up as 2, and then I also have 2 underneath. So the distance from the maximum to the minimum would actually be 4, right? Double that. So 3, 1, 2, 3, 4 would actually be down at -1. To have an amplitude starting at 1 and having an amplitude of 2, right? Then we'll move it up to 3 to have the maximum of 3. So I have an equation of the axis along here at +1. Let's say, y equals 1 is the equation of the axis there, right? So my minimum value is -1. And it would be drawn, well, what's halfway between 0 and 180 would be 90. So at 90, I'd be down at -1. Sorry, I'm drawing over top of the number 90 there. But I would come down, let's say, and come back up. And then same thing, I would come down and come back up, come down and come back up. Okay, so let's look here. I'm starting at a maximum, so then I know I would use cos. So y is equal to, I know my amplitude is 2 cos, and I'm starting at a max, so the amplitude is 2. It doesn't need to be negative or anything. My k value, right? So in order to get the k value over here to the side is 360 divided by the period. I can write it out again, but we should be starting to memorize that. So 360 divided by the period, and it told us is 180. So again, what's double 18? 36. So the k value is 2. So 2 cos 2, and I don't have any phase shifts here, right? Because I am starting at a max. So I can just say that it's 2x. And then, what's my shifting here? My c value. Well, I can figure it out, same thing. I can take my c value as the max plus the min divided by 2. So if the maximum is 3 and the minimum is -1, 3 minus 1 is 2 divided by 2 is equal to 1. So then I would go plus 1. So the equation is y equals 2 cos bracket 2x plus 1, and we figured it out. So now the question is, how do I do this two different ways? Right? How do I do this two different ways? So if I were to shift this graph, because it has a period of 180, if I was to shift the graph left or right a full 180 degrees, right? If I have this starting point here and I was to shift it to the right 180 degrees and instead have it starting here, come down and come back up, right? With a period of 180, come down and come back up. Now the graph would look the same, right? Or same if I shifted it left and instead it started there. So if I take that same period and I'm just shifting it because it's a period of 180, if I shift it left or shift it right 180 degrees, the graph is going to be the same. And in the equation that I have, I'm going to be graphing the same thing. even though the equation looks a little bit different. So what I mean is my amplitude wouldn't change. The horizontal stretch or compression, the size of it can't change because I need it to be a period of 180, right? So the 2x doesn't change. But I need to shift it 180 degrees, left or right. So it doesn't matter if it's positive or negative in here. So let's say it was negative 180, but just be careful here when you do that, because don't forget that the 2 has to be outside between, there has to be a bracket between the 2 and the x. The 2 has to be outside of the bracket. So it's kind of like you have a double bracket there, because if not, I'd have to factor out the 2. And if I factor out the 2, then I no longer have 180 because I'd have 180 divided by 2, right, instead. So here's another equation, y equals 2 cos 2 bracket x minus 180 bracket double bracket plus 1. So all I've done is did a horizontal shift of 180 degrees. And again, or I could have written that out as y equals 2 cos 2 bracket x plus 180 double bracket plus 1, and that would have been the same thing because I'm still keeping the period, I'm still keeping the amplitude, right? I'm keeping everything the same, just shifting it along the x-axis there. Okay, let's look at one more example here, and I'm given the graph. So cycle of the proportion of the moon that's visible to us from Earth. So proportion of the moon visible, obviously one would be 100% of the moon is visible, none of the moon is visible, and all the percentages in between, right? So determine the equation of the following sinusoidal function. So first I have to take a look at where I am starting here, right? So I am starting at a minimum. So let's number 1 here, I'm starting at a minimum. So I go back up to, let's say, the very beginning of the note where it said, if I'm starting at a minimum, is it sine or cos? And you can see there that it's cos, but the only problem is now that A is negative because I'm supposed to be starting cos at a maximum. So if I'm starting cos at a minimum, A is going to be negative. So step 2 could be then figuring out, and because I am starting at a minimum, I know that I have no D value, right? No horizontal phase shift, left or right, no shift. So step 2 can just be figuring out everything I know, like my amplitude, right? So I can just simply use the formula, max minus min divided by 2. Pull the numbers. My max is 1. My minimum is 0. So 1 minus nothing, 1 divided by 2 is 0.5, or I can write that in as a half. But don't forget, it's easy to forget. Don't forget that A has to be negative simply because it's starting at a minimum. So then I go back and I do add that negative in there, right? Don't forget that part. So then for my K value, right? My K value is 360 divided by the period. So I have to get that information off of the graph, how long it takes to do one cycle. So if I'm starting at 0, back up to the top, back at 0, back up to the top, back at 0. So that looks like one rotation there, looks like one cycle, right? So between 20 and 40 would be 30. So 360 divided by 30, 360 divided by 36, sorry, divided by 3 would be a K value of 12. I already said that D is 0. So I can move on to my equation of the axis, or C value, which is max plus min divided by 2. I can use the same numbers as here, or I can read it off the graph. The max is 1, the minimum is 0. And in this case, we have the same answer for A and for C, but we can see that's not always the case, right? And I can go ahead. So again, the equation of the axis, if I was at 0.5, just to show you, 0.4, 0.6, 0.5, right there, right? That's splitting the curve exactly in half. And then this is also showing No, I'll use a straight line because I'm not going to do as good of a job between here and here. Yeah, it would be the amplitude, right? So between 0 and 0 0.5, 0 0.5 and 1, I can see that my amplitude is 0 0.5. For amplitude, I never use the negative, right? The negative is just telling me that it's flipped. The cos is flipped over the x-axis because it's supposed to be starting at a maximum. And so because it's starting at a minimum, then I must have flipped it. There must be a reflection there. So I think that's all the information that I need to get the equation. If I do that in black, therefore, we have the equation as y equals a negative 0.5. I knew I was using cos bracket. Then I need my k value. So k is 12. And because there is no d, I can just say 12x and close my bracket. And then the c is positive, so plus 0.5. And just double check that that was a, that was k, that there was no d, and that was positive. And there's my equation. But I'm not done yet, because if I move this up a little bit here, it says, so I use the equation now to figure out the proportion of light that's visible on day 100. Use the equation, right? So I could have used, could have put that back at 0.5. I could have used my graph, let's say, for day 100, just to know roughly what our answer should be. Where day 100 is going to hit the graph is somewhere, looks like along here. But let's use the equation and see. So go back to my pencil. So x, right? This is x is going to be 100. So negative 0.5 cos of 12 times x, or 12 times 100, plus 0.5. So again, there's no, for BEDMAS rules, brackets would be to do 12 times 100 first, which would be 12 plus 2 zeros, or 1200 now. Now there's nothing to do in the brackets. There's no exponents. There's no dividing. So I have to multiply, which is all of this times this, before I add. So I would do the cos of 1200 first. So I'm getting my calculator out. I'm typing in the cos of 1200, and I'm getting negative 0.5. But then that's what the cos of 1200 is. Then I have to multiply that by negative 0.5 before I add, right? Because of BEDMAS rules. So be careful when you multiply it by another 0.5 that's negative. I should be getting 0.25 and then adding 0.5. So then obviously 0.25 plus 0.5 is 0.75. But what does that mean in terms of the question? So the question was, determine the proportion of light, how much light is visible on day 100. And so we can see here as well, this was 0.6, 0.7. You know, it looks like I was a little bit above that. So that looks like it's roughly between 0.7 and 0.8, so 0.75. So also graphically, I could double check that answer, right? But I should put a therefore statement. So basically 75%. So therefore, the portion of light visible, basically as much of the moon as we can see, the proportion of the moon visible, the proportion of light of the moon visible on day 100 is, let's say, 75%, or 0.75 instead of 1 being 100%. Okay? So get some practice with this. I think we've done enough examples to get you started. The homework here, sorry, I have listed there. You can kind of see it. Homework page 391, numbers 1, 3, 4, 6, A and C only, 9 and 11. Give those a try.